Hello, this is my ELEC351 coursework for my environmental alarm. This video is being created to help demonstrate the functionality of the device and ensure that as well as to reinforce the vivo of this coursework. So let's begin. First, we shall begin with the SD card we shall save our samples to, currently loaded into a adapter. This shall be plugged into my computer. As you can see, it has been found by the computer, and we have one empty file called sample values, which we will be saving our values to. How do I know it's empty? It's empty. I shall now close this, eject, and take it out the adapter. There we are. Put that there. And this shall now go into my board so I can save the values to. Here it is. And I shall now plug it in as seen. Very nice. I shall now put the board here on my stylish mouse mat and plug it into my computer. Here is the code I shall be running for this coursework. Here is the wire plugged into the board, and here it is being found by my computer. I shall make it the target and run a new build version of it onto the board to prove that it is this code what is running. Background tasks erasing. We should get a new build any second. Shall know the build is done because we shall get outputs from the serial monitor. Please stand by. And here we are. Start and coursework main indicates that we've started the coursework. And we've initialized and written to the SD card to prove this is the first write always takes longer. I thought I would get that out of the way. And as you can see, we are getting three values to the monitor. One for temperature, one for pressure, and one for light level. Now, how do we know these are coming from sensors and not just random integers? Well, here is my board. On this board, we have a thermometer, a light-dependent resistor, and somewhere a pressure sensor. Where? I do not know. And I shall demonstrate. If we look at the temperature, it is currently at 28. When that hits 30, we will hit our upper boundary. I'll go into this more later, but if we hear a buzzing sound, that's why. As we can see, if I put my finger onto the thermometer, we should see a change in this value. As you can see as well, we've got a reduction in temperature. My hand must be pretty cold. And as it's warming up now, you can see it goes up. Keeps going up. I shall also use this time to show the light level currently is 1.79. If I put my finger onto the LDR, you will see an increase in light level. I shall also note this shall also set off the buzzer, as by covering it, it will break its threshold. I've seen here. As you can see, the buzzer has activated. We have had a message to indicate it has breached its boundary, and our light level is now at 2.99, going on 3. There is another write to the SD a minute later. I take my finger off the thing and it has returned to normal and deactivate the buzzer. Now the buzzer does have a second delay. This is to allow to prevent noise, as 2 samples of similar value must be gained until we set it off, instead of 1 which could just breach it due to noise. That's why. And demonstration again. There we are. take it off. Now, along with the alarm and change sensor values, we also have the LED bar, which indicates these values. Now, currently it's set to temperature, and it is pretty high because its current temperature is of 29. But if I put one of my fingers onto the thermometer, which are pretty cold, we should see a drop in this temperature and a drop in the LEDs. Currently it's 27, 26. We should see an update in a second, and there we are. And if I take my finger off, the temperature rises up again, and we should see an increase in value by the lights. It might have happened when I was looking away. I'm hoping. There we are, back at 29, and we had another. Now the maximum this goes to is around 30. I think 33 specifically. But I should then put my finger on again, which now it's going to 38, and we're seeing a reduction. We're now at 27. No, it's gone back 28. Let's move my finger. That's right, different finger. 27. 26. And I'm covering the light sensor with my hand. Nice, let's move it. Now you can see there is a delay with the bar, and that is because of the work intensity to the CPU it does, and thus I've set it to only go off update every 5 seconds. Could probably improve it. Ran out of time. Now this bar doesn't just show the temperature value. For if we input a L for temperature into the command terminal, I'll put the board in view as I do this. If I press L for light level, we should see the bar update to show the light level. There is a delay, of course, for 5 seconds. There we are. As you can see, it is now showing the light level on the bar. And if I cover the LDR with my finger, the value goes up. And if I remove it, it goes back down. Now this also works for pressure. Now I can show the pressure on the thing like so. Give it a second update, and there we are. And I can change it back to temperature, shall I desire. T for temperature. Nice. Now that is the main functionality of the board. We have got a user input. On the terminal, we get in a sample every second, and every minute we get a write into the SD card. We've got a bar LED showing updating and an alarm with noise protection. We'll just wait until another read. Shall I say write? And then I'll show you the SD card file. Hoping this is near the end of a minute. There we are. Now this is about 8:30, so if we at 9:30 I'll come back to this and we should see another write. But a quick look at the code, we can see it is separated to H files and C files for each segment. This is currently the main, where we're reading them. We've got ones for temperature, and we've got multi-threading using event queues to stack the timing of it. One for high priority, one for medium priority, and one for low priority. These are our threads. We also have one specifically for the bar due to its high load intensity. These are called in the main as seen here. We also have the LED bar initialized, and we show the message to show that we started. Now we are reaching 9:30 any second now, so I'll go back to the thing, and we should see up. There we are. Look at that. Pretty good. Well, I'll go through here, a quick look at through the files. Here is my bar flash file. You know what, let's start from this sampling. It's probably better. As you can see, these are my shared sensors between shared values between all my H files, C files, and the main. This one reads the values. as well as sends to the medium thread call, as well as the low priority queue a thread for the data logging, the serial output, and for the alarm. Here is my C file for my alarm, for my output. It just prints to the terminal, and if the noise count, which I use to indicate out, we'll get another right in. And now I'll be doing that until I finish explaining. This one just saves the values to the serial terminal, as well as if the noise count for basically to prevent noise. If that one is active, we also say that's how we get our message. Here's our data logging. This one saves it, the values into pointers, and puts it into a queue called buffer. Where after a minute has passed, we then put them into one single value called empty buffer, kind of ironic. And then we print that to SD in one single line of code as by the brief. Here is my program for alarm. It takes the shared values, and then if it's between the values for breaching, the alarm goes off. Here is my noise thing as explained. Hold on, we shall get it right now. As you can see, if noise is less than 1, we increase it by 1. And then only when it's by a value of 2 or a value of 1 do we actually play the noise. This is to prevent noise from our sensors causing the buzzer to go off by accident. As you can see, our values are between 0 and 2.5 for the light level, 0 and 2000 for the pressure, and 20 to 30 for the thermometer. Again, as you can see, it's currently at 1.5 the light level, and if I put my finger on the LDR, if it goes above 2.5, as it will, the buzzer will go off. It's 2.9, it is going off, the message is there, and I've turned my finger off, it has dropped, and the finger stopped. Next, we've got the user input, but first, and about now. Yeah, here's my user input. Basically, we read if a button has been pressed by the user, and so long as it has got a value, if it is one of these 3 options, we change this integer to correspond for it. This is so for when we do bar flash, we have again a mutex sample lock to the shared values as seen in all the other previous bits of code. To determine which value show, if we have that %, as just seen, which depending on its value, depends on what calculation we do. Rounding to give us our bottom and top limits. And then basically, here we are. It divides the 24 LEDs by 3. It's 3 segments for red, green, and blue. And then it fills them up according. And then we do a bit masks to shift it, so we get the actual value written. And that just gets written to the strip. And that's the code. Now we just have the right. So I'm going to stop the program by just unplugging it and demonstrate that the SD card now has data written to it. As you can see, I'm taking out the SD card. Nice. And putting it onto my adapter and then into my computer. Here it is. Sample files. But what's this? Values. Here is the message saying we started. And as you can see, they're separated for temperature, pressure, and light level. Here they are. Just keep scrolling. As you can see, we've went on for a lot, and there's a lot of samples. Let's just zoom through them. They're all there. Let's just close this file. So thank you for watching and spend this time, and hope you have a great day. Goodbye.